Joe, we left on a
Hello, hello.
cliffhanger on that last one. Do
I
you
know. I
remember?
haven't slept for days.
I know, I know, I know. I've been like, oh, I so want to ask Joe this question and see what he says. And I'll just get right to it. So my question is database sprawl, and where different people, I mean, there are more databases in Excel spreadsheets than anywhere, but I'm not talking about Excel spreadsheets. I'm talking about even SQL databases where there's similar tables on multiple databases, but like the column names aren't the same. So even when you bring the code over to that environment, it has to be tweaked. And then when the code starts getting tweaked, it starts to, become more and more different. And we talked about that and how you could have a centralized library of your modules and figure out the similarities there. But what about similarities in the schema and the tables structure? What could we do to find that?
Yeah. Yeah, let's say you extracted out the schema for everything and then you went ahead and embedded it all. So said, hey,
Okay.
here's different embeddings that represent my orders table, my order details table, my
Right.
sales table, my person HR table, my property table. So that definition, that T-SQL definition could be something, for example, you could embed. And it would get you similarity like you're implying. So it could go,
Okay.
okay, here are objects that are similar in vector space. So these embeddings are close, like here's the order related tables, here's the property related tables, here's the HR related tables. So you could see that kind of distance represented.
Would it show
And it
you
would
like,
get you far enough to get, at least a cohort
okay.
of different tables. Now, what it's not doing though, and I think that this kind of maybe this is what we talk the next few minutes about, is it doesn't bring you as far as classic methods. Like vector search is good for, hey, these are close in distance, but it doesn't solve what I think is beyond your question, which is also, okay, do we have some redundancy, or which one of these are not foreign key related, or where are we saying the same column name but in 15 different ways, which is actually
Yeah,
the
like first
data
versus
architect
first
nightmare.
name versus, given versus, would it
Yeah,
see?
it's like that level of precision is where you don't go to vector search. Like,
Okay.
yeah, and we can go over, like, I have like a little list of like anti-patterns of, like, because the biggest danger, by the way, there's two dangers. We talked a little bit a couple of episodes ago about, people are like, I don't want to learn about any of this. And then you're going to have the opposite end where it's like, let's use it to solve everything. Now I
Right.
can just stop doing anything else but vector search. And
And you can't do
that
that.
has its set of anti-patterns. So we
Right.
could talk about that.
So one more question. If I have
Yeah,
two
yeah.
tables and one customers, like let's say one's called customers and one's called stupidly buyers or something like that. And one has 18 columns and one has 17 columns. But like 14 of the column names are the same. But then one is first and one is given. So but 14 columns are the same,
Yeah.
different number of columns, different table names. Would it see enough of that it would see
If
that,
that's
right?
like two different, yeah, if you have, so if I am embedding a table definition, like my
Yes.
whole create table, and
Data
it's got,
types are
yeah,
similar or the
and
same,
then you're
really.
doing another one, then my assumption is going to be that it'll be closer in
Okay.
distance than something that has none of the shared
Yes.
column names
Yes, of
or
course.
even
Okay.
equivalent column names. So
Okay.
anything that's semantically related.
So you could get closer. And then what might you do to further that? Would you just use a regular search on it at that
That's the thing.
point?
You would, yeah. So this is where maybe it'll help to step back and go, okay, here are some things that vector search does not do well.
Right. Okay.
So I have a few different, like on my list, top one, exact match requirements, for
Yeah.
example. That's not something where vector search does well. So when you want to say, hey, I need properties on this street in this city, you may get a bunch of things that are near that street name, might even have that street name, might even be in that city or near that city or that state, but you're not getting that level of precision that you were likely asking
Right.
for. Like, I want, no, I want
Okay.
it for that street.
Right.
A second one on the list, rare terms and domain vocabulary. These embedding models that are used to generate the embeddings are not magic. So if there's institutional knowledge that's within your company that at our company, we call it, node XYZ, and
Yeah.
it's not anything that it
Farkle
would have been trained on.
72.
Yeah, you're out of luck there. So it
Right.
will not be able to
Right.
guess that. And by the way, this is particularly nuanced because even let's say you have business rules that One scenario I remember running across was related to like match of address corrections. So if I get this address, it should be corrected to that address.
Right.
And vector search can get you near to the obvious, like logically, it can go, okay, this looks similar. This is often an expansion. ST can be street. It can do the things that are like global knowledge,
Mm-hmm.
obvious. But if it's something that only you would ever know it, there's no
Right.
logical leap that would get you there. Vector search
Can
isn't going
you
to solve that.
can you like we could add noise words in the past and things like that? Can you add like what if you had a product that was the original name was Widget 1 and now it's called Farkle 7? Is there a way to say those are the same thing in
You would
like add it?
not with vector search. I mean, you
Okay.
would have to. So, and that's the key thing. So, if it were globally, like in the whole world, it knew this because on the internet we had a global mandate that
Right.
Farkle is the new name for the.
Yeah,
So
exactly.
if it were
Yeah.
trained on that, it might be smart enough to make that leap.
Okay.
But there are many times you can think of all the odd things that happen in business
Yeah.
where that is just an
That's
institutional knowledge
domain
fact.
knowledge that's
Yeah.
just
Yeah.
not something that they've taken from the corpus of internet knowledge and put into
Yes.
these language
So then
models.
you are literally having to hard code. Like that's a hard coded. Like it sucks, but that's a hard coded rule then, or
Yeah.
that's a case where you okay, look at this table. Another big one is the
And you'd be
negation.
better off updating and cleaning that up through a little bit of time and analysis and then doing your analysis
Yeah.
further from there.
Right.
Yeah.
Right. Yeah. Absolutely. So oftentimes people. By the way, that would be the ideal is if you could just say, hey, vector search can wholesale replace this. But again, these are the corner cases that are actually critical, especially if you don't have a human in the loop.
Right.
Meaning
Right.
it must be auto corrected and there's nothing else that you could do about it.
Right.
Other big one is the negation. So, example I had in vector
That's
search and
always
practice.
been difficult in
That's a
every
big one.
language.
And vector search, it's particularly crazy making because you could say, okay, I want a house with no pool. I don't want any pool, and it'll go great pool, 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 pool. Because again,
You said pool.
not.
Do you want a
Yeah,
pool
it's
day?
yeah. So the big thing is the negation is I don't even want to say that it's ignored because there can be cases where it might get it right, but it's
Right.
just going to go okay pool anything that you mentioned or took that's part of the embedding. It's
Right.
going to just be closer in distance. So
Interesting.
how would you even solve that? That's classic pattern. So it would be you if you're using full text search or if you're using standard not equal to, you're
Or you have
excluding
a you have a column
or you have a
of
flag.
yeah, exactly, a
Yeah.
binary like has pool, doesn't have pool, bit, something like that.
Yes.
That's a good way of
Yes.
dealing with it. Okay. Wow.
Let's see. So we talked about negation patterns, rare terms. The other one is like just regular identifiers or things that you want to qualify. Example I had in the course was where I'm searching for properties less than $400,000, 4 bedrooms, 3 bathrooms, and you
Right.
hear all those different conditions. Those are conditions that should be in your where clause. Like those are
Exactly.
things like
Because
you've
those
got
are
columns
exact
for it.
matches or,
Yeah,
or less thans, easy.
yeah.
Yeah,
Because
easy.
it won't work. You will get a property back that based on the property description if that's what you're embedding. Even if you're embedding, if you say okay, I'm going to actually do a concatenated string of all the different things like bedroom, bathroom, square footage, and you do a big string and then you embed that string, you still have an imprecision there.
Yeah.
And the key indicator will be your customers are going to be frustrated because it's like I said less than 400,000, you're going to see $1 million houses
Right.
pop on.
Well, and that's where, I mean, one would say, and in a schema design world like we've been in for years, where we didn't have pattern matching, really good pattern matching like we now have with vectors, right? But those are the conditions that you've already pulled out, and they are domains that you are searching for today. The power is where you can combine those things. But there's also tricks in knowing what happens with equality-based searches and semantic search and who takes precedence and so forth. So
Right.
there's still tricks and importance here, but it's very cool because combining the two is really where you get the most power, I think. I mean,
Yeah.
and
And I
looking
think
at
it's a must-have. I absolutely agree. And it's so hybrid is the way. So I think that is an expectation to set. I think DBAs will get this intuitively out
yeah,
of the gate, but
yeah,
I think it's a stakeholder management. Like, no, 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 we can't just use that for everything. You still need to have some structure, and you have to have some
exactly.
predicates.
Because some
And
of this stuff
even
is
from a
absolute.
performance perspective, it might, let's say it was the greatest, like let's say vector search could handle all the things that I just mentioned. What are you doing about the actual execution of this? So think about the query execution plan itself. Like what are we, so even then, from a performance and scale perspective, that's not tenable.
Yeah.
And so just something to consider. Actually, that should be our next episode, is the database design discussion, because I think
Okay.
that dovetails nicely. Yeah.
Well, that's perfect then. So thank you, Joe. Thank you
Thank
for
you,
getting
Kimberly.
my question answered. I will sleep well tonight.
It was worth the wait. All right.
Thank you.
Likewise.
All right.
Thank you.
Bye.